what's the deal with
mechanics?
Well, Jerry Seinfeld, world-renowned comedian and creator of the hit TV show Seinfeld, why don't we find out? Mechanics is the area of science concerned with the behavior of physical bodies when subjected to forces or displacements, and the subsequent effects of the bodies on their environment. It can also be defined as a branch of science which deals with the motion of and forces on objects. Now, this does seem quite encompassing, as mechanics is about things that move and have forces acting on them. Well, at a simpler level, mechanics is exactly that. Think, your resultant force diagrams and how big your arrows are and what direction they point in. This field of mechanics is what you could call classical mechanics. This is stuff that's way easier to understand, like calculating the trajectory of a football. Stuff like that is so feasible to understand I could even get a practical example. Wow, would you look at that? Who did this? So, as you can see, I've kicked a football with an unknown force and unknown angle, but you can still map its trajectory if you're able to see, say, the first half of the clip. You could tell me where the ball is going to go. But now, after that little flurry of humour, I'll lead into a nice little left hook of history. So, mechanics, much like gravity, simply didn't exist until Isaac Newton came along. Thank you. Jerry Seinfeld did help me out with that one as well. But in truth, as far back as cognitive carbon-based life forms have existed, there has been an understanding of mechanics. Although crude, you could easily say that any moving animal would have some understanding. And as caveman began to, say, throw spears, they would observe simple phenomena such as putting more force behind throwing a spear will make it go further or faster. However, there was a stagnation in the progression of science and understand the world through mechanics in favor of a far more legitimate scientific endeavor, alchemy. But during the Renaissance period, science became far more self-actualized and revolutionaries emerged such as Galileo and Isaac Newton, the latter of which would set the groundwork for all of what we know as classical mechanics. Now, we're going to hit you with a little question. If a cannonball must breach a heavily fortified castle, and it takes 1,000 newtons of force to break the first wall, and it takes 2,000 newtons of force to break the second, how much force will it take to break the fourth wall? Classical mechanics is the application of mechanics in all practical ways. First moon landing in 1969, in fact, was done with what boils down to Newton's laws of motion, a camera crew and an impressive set of the moon's surface. But classical mechanics only covers one of the four fields of mechanics, but a lot of what applies in day-to-day life, or what can even be observed by humans without theorizing. But when things get very, very fast, or things get very, very small, the classical rules of mechanics get a bit bendy. Quantum mechanics. It's small. It is proper small. Quantum mechanics concerns the nature and interactions of the smaller scales of energy and mass in atoms and subatomic particles. Now, I know little to nothing about quantum mechanics. I'm going to talk about it. Energy was always thought to be a continuous flow of stuff, but it was soon determined to have divisibility by Max Planck, that he could find the smallest amount of energy that can exist in one thing, and they coined this a quanta. Now, because these exist in quasi-particles or photons, they can interact mechanically. So you have a set of rules for how these interactions occur. They are tweaked from the rules of classical mechanics, but they will still have the same principles. Now, this is a graph that was really important in the late 19th century. So I know what it means. I mean, not really. I just know that this line is wrong when you shine UV at a black body, and that was really confusing to people. And I know that this line is what happened when the experiments were conducted, shining UV on a black body. But enough with the stuff I'm not supposed to teach you. Now that I have expelled just about all my knowledge, here is a list of long words that I heard Brian Cox say. Now that you understand that light can be a particle, packet of energy, or photon, you can explain certain phenomena such as frequency affecting the rate of electron expulsion in the photoelectric effect. In fact, it was Einstein that came up with the idea to prove that light acted as a packet of energy with this photoelectric effect experiment, and was instrumental in doing so. That leads into the next field of mechanics, relativity well. Relativistic mechanics applies to very fast-moving objects, ones which approach the speed of light. There is a set of rules designed to account the asymptote of energy mapped against speed when approaching 3 × 10⁸ meters per second, as well as all the interactions and collisions of objects travelling near the speed of light. This area does overlap with quantum mechanics is due to the asymptote and kinetic energy equaling half mass times velocity squared. Only objects with atomic or subatomic masses can reach near the speed of light. I think that just about does it. You now have a concise but encompassing understanding of mechanics, and you now know that mechanics themselves are not just people that do your MOT. I may have mentioned there was 4 fields of mechanics. I'm not even going to try to explain quantum field theory. Here's all the Google results that come up if you're quick at reading.
I used to cop a lot, but never cop no drop. Hold mics like ponytails tight and bobble ops. Stop, stick around, come through and dig the sound of the fly.